Hello everyone, my name is Miracle Godwin Obo, and this is my submission for task 1 of the CodeAlpha Cybersecurity Internship. In this project, I developed a basic network sniffer using Python and the Scapy library. The application capture live packets, they analyze them and display useful information such as IP addresses, ports, protocol, service, payload, and also a section that display capture summary. So this is my GitHub repository for the project. The repository contains the complete source code. The project documentation is also contains screenshots, installation instruction, and the project files. The main objective of this project was to capture live packets. We analyze the packets information, we understand the TCP/IP networking, and display useful information such as source and destination IP addresses, protocol, ports, services, payload, and a packet summary. The application supports user-defined packet capture. It detects TCP, UDP, ICMP packets, identify common network services. We also display payload information and generate a protocol summary after I capture the packets. So, and the technology I use to develop this project include Python 3, I use Scapy, Visual Studio Code, GitHub, and also I test. I use both Windows and Kali Linux to test it, as you also display it. So before I open Visual Studio Code to explain my code, I will also briefly explain how this application work. This application work capture packet based on user inputs. The user enter the number of packets to capture, and for instance, if you ask the user how many packet do you want to capture, if you enter 4, 5, 6, any number you put, it will capture the live packet from the network interface. And also each packet I design it to that, so that each packet will be inspected individually, it will be inspected differently. So it will show the time, the source IP address, destination IP address, source port, destination port, services, maybe HTTP, HTTPS, or any service. It will display it. It will also display the protocol, packet length, and payload information. It will display it. So it will also display the capture summary. We will explain the summary of every packet that is captured. Maybe total number of packet that will capture, total number of TCP, UDP, ICMP. So it will display everything. So before I come to explain the installation part, we will now go to Visual Studio Code. We explain our code. The project uses the Scapy library to capture and inspect live network packets. So I imported Sniff from Scapy library. But before I proceed, I would like to explain the Scapy so that everyone will understand. Scapy is actually a Python library, a collection of already made code that know how to capture network packets, read packet content, also to build packets, send packets, analyze packets. So it has already understand how to do all those. So we import Sniff from the Scapy library. So, and also these names also help Python program to observe all the packet that is passing over the network. So for instance, if you open Google, if you are watching video on YouTube, if you use WhatsApp web, if you ping server, or you are updating Windows, your computer is constantly sending and receiving packets whenever you do all those stuff. And Sniff lets Python program to observe those packets. So that's why we have to import Sniff to the to that's why we have to import Sniff also. And also I imported IP, TCP, UDP, and ICMP protocol layer, so the program can identify different packet types. Yes. I also import raw. I also import a raw layer to inspect payload data and data time to display the packet capture time. And it is very important to import this raw, because we import it because of a payload section. This section, the payload is usually stored in a raw layer. And a payload is actually a working data that is delivered, transport, or execute. In a simple word, the payload is the data that are inside, is a data that is the actual data that are inside the packet. So that's the meaning of payload. So, and the payload is usually stored inside this raw layer. So that's why we import this raw layer. We also import date time for it to let us know the actual time that the packet was captured. So we move to next section, common ports. As you can see my comment here, common ports. So instead of displaying only port numbers, I created a dictionary that map common ports to their corresponding service, such as HTTP, HTTPS, secure shell, domain name system, file transfer protocol, and simple mail transfer protocol. So for instance, if the Python see port 20, you already know that is file transfer protocol data. If it sees port 21, you also know file transfer protocol. You see port 22, you know secure shell. So that's why we all actually use this thing. And for my viewer, in case you do not understand, the port is a virtual doorway or connection point where information flow between the computer and the external device or the network. So that's the meaning of the port. So that's why this section is also important. This section simply print the application title to improve user interface. That's why we use it. This is equal to times 20. That means we print this times 50. I mean, that means it will print this is equal to into 50 times. And then basic network sniffer. Under it also, just like this comment now here. This is equal to program title, and it's equal to this is just a comment for viewer to see, but for user to see. That's why I use this print, so that user can just to improve user interface. So we move forward. Why true? The program asks the user how many packet they want to capture, and then we use this try. I use a try exception block to prevent the application from crashing. When invalid input is entered, for instance, when you if it asks you how many packets do you want to capture, and you go and enter ABC or alphabetic letter, it will not accept it. So that's why I said I use packet count is equal to integer, and you allow the input. So the user will just enter how many he went, and it must be a number. That's why I use this integer. And also the number must be greater than 0 from 1 upward. So that's why we use this if packet like if packet this packet count is equal is greater than 0, the program only accept positive number before continuing. That's how this section go. And under this packet is equal to sniff count is equal to count packet count. This is the core of the application. The sniff function from Scapy capture. It function from Scapy capture the number of packets specified by the user. So like I already explained the sniff for you, just to monitor the packet that is passing over this thing. So now continue this initial variable. We set the packet number to 1 because we want it to start counting the packets from 1 because we want it to analyze every capture packet. We want it to be process them individually. So that's why we use that for. That's why we start from for packet is equal to 1. And if you come here for packet under this section, you see that I said for packet in packet. So we want it to process the packet that it capture individually. So for user to understand and to be able to read the packet very well. So and we use if IP in packet. This section, the application first check whether the packet contain IP layer. So that's why we use this. And if TCP in packet, also the application identify whether the packet is TCP, UDP, or ICMP. So that's why we use this place. And and if the yes, so that's why we use all this section just to identify whether the packet is TCP, UDP, and TCP. So for this section, if destination port in common ports, this place using a dictionary created earlier, if you remember, we create a common port that we created earlier that was explaining. The application will translate port number into recognized service. It will translate if it's port 80, it will translate, it will know that the application will know that this is HTTP. If it is port 443, you will know that this is HTTPS. So this is why we use this. And if moving to the next section, and we use if raw in packets. If the packet contains payload data, the application attempt to decode it. So that's why we use if raw in packet. So immediately the packet contains payload data, the application will try to decode it. And this is interesting part. Let me explain this. If service equivalent to HTTP, like I said earlier, HTTPS is Hypertext Transfer Protocol secure. This HTTPS port 443 is secure because it is all the data, all the payload inside this packet is encrypted. You will not see it in plain text. It's encrypted. So the program will not be able to read it. It will be showing different that's why we use the HTTP. This HTTP payload remain encrypted. So instead of displaying unreadable encrypted bytes, that will display things that you cannot understand. So the application will just simply display that encrypted HTTP data. So that's why we let this one to understand it. So I'm saying yes, that's why we understand this one. And let's move to the display section. Finally, the application display. This application display the analyzed packet information include IP address, port, service, protocol, packet length, and payload. All these prints will display everything. So that's why we use this section. And packet. Remember I said that we want the packet to be display. We want to be display the capture packet individually to process them individually. You don't want them to just mix all the packet that is captured together. So that's why we use this packet number plus is equal to 1. So this packet number, when you come, you said packet is equal to 1, you analyze it, you will come packet 2, you analyze packet 2 also, so and so on and so forth. So this last code, after all the packets are analyzed, the program generates a summary showing the number of TCP, UDP, and ICMP packet that is captured. So that's before I go and explain how how you can install the application. I quickly explain. I was mentioning packet since. So I wanted to quickly explain the meaning of packets for my viewers. A packet is a small unit of data that is sent over a network. When you send a message, you open the website or you download the file. Even the data and you download the file, the data will be broken into packets. Each packet contains source address, where it came from, destination address, where it's going, the portion of actual address. That is why I call it payload earlier. The size of that payload, you also have it. So all these data are called packets.